Hi everybody, my name is Elana Goldenkoff and I am a student at the University of Michigan. I study how different regions of the brain work together to control voluntary movement. Welcome to my science lab. I have my mom with me today and she's going to be helping us out learning some really interesting things about our brain.
I'm really excited to be here, thank you. And I'm really mostly excited to see everything that you've been learning here at the University of Michigan about the brain.
So let me ask you a question. How many senses do you have?
Oh, well that's easy. Everybody knows. We learned that, I think, like in kindergarten. There's the sense of sight with our eyes, sense of hearing with our ears, sense of smell with our nose, sense of taste, and there's a sense of touch with our fingers.
Yeah, that's exactly right. But there's also way more than that.
Really?
Yeah, today we're going to be learning about two special ones. The first is our sense of temperature.
Well, okay, that's, what do you mean sense of temperature?
How you know if it's hot or cold outside.
Okay, that seems pretty easy.
Yeah, in science we call it thermoception.
Thermo what?
Let me show you. Thermoception. Thermo means temperature, and ception means sense. So this is how you sense hot and cold. Here I've drawn a picture of a piece of your skin. So if you were to take your skin and look at all the layers, this is what it would look like. And there's a lot of stuff in there. Here's some hair cells, and then you have your nerves, and then you have lots of different types of receptors. These are types of nerve cells that sense the world around you. Today we're going to be talking about one type called free nerve endings, and they tell you when you feel pain, itching, and temperature. Let's do an experiment to show this. This is an experiment that you can do at home to learn about your sense of temperature. I have 3 bowls of water. This one is very cold water. This one is very hot, but not boiling water. And then this one is room temperature water. You want to put one hand into the cold water and one hand into the hot water.
Ooh, that is really cold. Ooh, that's hot.
And then leave them there for about 30 seconds. So while her sensory receptors are getting used to the temperature, let's go learn about what's going on. So you have some cells that sense cold and some cells that sense hot, and they both send information to neurons, which then send information to the brain. In order to talk, they use a very special code, and they send this code at specific frequencies. So, for example, the cold one would say beep, 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 and that is something that the brain understands to mean cold. The hot one has a different type of pattern and a different type of language that it speaks. So this one says beep, 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 beep. And then that's how the brain knows that it's experiencing hot. Let's go check in with our experiment.
This hand is so cold, and this one feels so warm.
Okay.
It's so weird.
Now take them both out and put them into the bowl of room temperature water. What do you feel?
Oh my goodness. This one, the hot one, feels really cold, and this one now all of a sudden feels really hot. How'd that happen?
Yeah. So basically, those cells that were getting used to saying the hot language now it's getting confused and it's like shocked because this water temperature is so different that it switched to speaking the cold language. And the same thing happened with the cold ones. They were used to saying the cold beeping patterns, and then now they experience a big change of temperature, so now they're speaking in the pattern that the hot one would normally say. So now we're going to learn about one of the most important senses that you use every single moment, your sense of proprioception.
Proprio what?
Yeah, like proprioception. Proprio means one's own, and ception means sense. So it's your sense of one's own body. Let me show you how this works.
Okay, this is a little confusing.
So close your eyes.
Okay.
If I put one arm like this, I want you to match that position with your other arm.
Okay, I think that's pretty easy.
Exactly. See, your brain was able to know the shape and relative location of this arm, so it could do the exact same thing on that side.
You know, I never really thought about how that would be difficult, or, you know,
It's really important in order to do every single movement that you do every single day. Here's another example. If you close your eyes, you can tap the tip of your nose, and that means that you know exactly where your nose is even when your eyes are closed.
I want to try that too.
And you can do this at home.
Wow, it's very easy, but I never really thought about how it could be, you know, what the brain is doing.
Yeah, so let's look at an example. Here is your elbow joint, the one that goes like this. You have muscles that control this joint, and inside those muscles are receptors. Remember how we talked about receptors in the skin that give information on temperature? These are receptors inside the muscles that give information on the muscle. So there's one that is at the end that gives information on tension or tightness. And then there's another type that is inside the muscle and gives information on how long it is. This tells your brain exactly where your arms and legs and the rest of your body is located.
Wait a minute, Elana. That's an awful lot of information that the brain has to take in. It's constantly, it seems like, it's getting it from all the 5 senses that we talked about, plus you're telling me that there's those senses in the skin called thermoception, and now the muscles too? How does the brain do all this without getting confused?
Sometimes it does. Remember the experiment with the water and how the brain thought that the temperature was something else? Let's do another experiment to learn about how I can get confused about proprioception. Here's another experiment that you can do at home. All you need is a mirror and a friend. So I want you to start by putting one hand really close to the mirror, the side where the mirror is.
Like this?
Exactly. Then take the other hand and set it down about a foot away from the mirror.
Okay.
Perfect. Now, let me ask you, where do your hands feel like they are relative to the mirror?
Oh, well, my right hand is really close, and my left hand feels like it's a foot away. I mean,
Wow.
it's exactly
Perfect.
Like
So your sense of proprioception is telling you exactly where your arms are located. Now I want you to try something.
All right.
Why don't you look into the mirror and look at the reflection of your hand?
Oh
You
my
see
gosh,
it?
yeah, I see it. It looks like this is my right hand, but it looks like in the mirror that's my left hand.
Cool. Now I want you to take both of your pointer fingers and start tapping them at the same time. Do this for about 10 seconds. 7, 8, 9, 10. Now let me ask you, how far away do your hands feel from the mirror?
Oh my gosh. I know that my left hand is far away, but it's incredible. It feels like it's just like right next to the mirror. Like it feels like my 2 thumbs are almost ready to touch.
Yeah, wow, that's really cool. So when you have a conflict between the information coming into your eyes and the information coming in for your muscles, your brain has to decide which one is more truthful and which one to believe. So at the beginning, it decided that the proprioceptive information was more accurate, and that's why you felt the left hand far away from the mirror. Then, after looking into the mirror, it decided that the visual information was more accurate because it was seeing the tapping at the same time it was feeling the tapping. And your brain just decided that location is more accurate.
That is really cool. So my brain got really confused about what was really actually happening because my hand really is far away in reality, but my brain got tricked by my visual sense to make it seem as though I'm feeling it really close.
Yeah. So today we learned about how the body senses the world around it and also how it senses its own relative position. We also learned how those nerve cells communicate that information to the brain when it's functioning in a healthy way. And we also saw with some experiments how we can trick the brain into making it function not normally. This can sometimes happen with diseases or if you have some sort of injury to the brain or to the body. My work is studying why that happens in those people and how we can fix it. Anyway, I hope you had fun today and you learned something about the brain. Bye!